I will be your host today, along with Vadim Chechenko, founder and CTO of Percona. We'll be discussing managing big data with Percona Server, XtraBackup, and Tungsten. So we have a lot of people signed up today. Folks will be trickling in as we go, but I think we have a very full presentation for you, so we'd like to get started. One thing I'd like to say before we get too far in is we do have copies of these slides available, which we'd be happy to send to you. We have contact information at the end. You can also just send email to sales@continuent.com and we'll get you a PDF. So with that, let's go ahead and jump in. We'll do some short introductions today, both of Percona as well as Continuent. We're also going to briefly describe the big data problem. I think that if you're in this webinar, you probably are quite familiar with what it is already, so we'll just make sure that we touch base on some of the key issues that we've seen. And then I'm going to turn things over to Vadim to talk about Percona Server as well as XtraBackup, a couple of really key pieces of software in attacking big data with MySQL-based systems. And then after Vadim goes through that, we'll come back and talk about Tungsten, which supplies replication and clustering for big data. And then finally, we'll conclude by talking a little bit about our commercial services and support, so you know how to find us, what we actually offer, and then we'll open it up for questions. As we go along in this webinar, I should point out you can go ahead and type in the questions. If we do see them as we go along, we make an effort to answer them. Otherwise, we'll catch them at the end of the presentation. So with that, I'd like to turn it over to Vadim to talk to you a little bit about Percona.
Yes, hello guys. I'm Vadim Tkachenko. I'm a co-founder of Percona, and I'm active author of MySQLPerformanceBlog.com, and I'm also co-author of a High Performance MySQL second edition book. And Percona was founded in 2006 by 2 ex-MySQL employees from High Performance Group. So we understand when we speak about performance. And Percona provides consulting, support, training, and development services around the MySQL and LAMP stack. And we also develop 2 known open source products, it's Percona Server and Percona XtraBackup, which I will cover later in my talk. Robert?
Okay, great. Let me just give you a brief introduction to Continuent. I should mention that I am, as you saw probably from the front slide, my name is Robert Hodges. I'm CEO of Continuent. I'm the author of the Scale Out blog, also the main designer of Tungsten, which we'll be talking about at the latter part of this presentation. So Tungsten, Continuent, we style ourselves as the leading provider of data replication and clustering for open source relational databases. We have some very interesting technology in this area, which we'll be demoing for you later in the talk. 2 main products are Tungsten Replicator, which is very high performance replication for high performance and flexible replication for MySQL, as well as Tungsten Enterprise, which is a commercial product that allows you to build clusters using master-slave replication, and we'll talk a little bit about that as well. Our offerings include consulting on Tungsten itself, plus replication and clustering in general. We have a long history in that and a great deal of expertise in that area. And we offer subscriptions for our commercial products, namely Tungsten Enterprise. So with that, I'd like to just very briefly touch on the big data problem. We just have a quick slide here. What we find, both Vadim and I have spent a lot of time working with different types of applications, and we know, as many of the folks on this webinar know, that you are dealing with increasingly large sets of data on MySQL. So the first part of the big data problem for MySQL systems is just the fact that you have a lot of data. So things like application performance become very, very key, and being able to diagnose what's wrong with performance. Issues that don't really matter when you're just running a blog like a MySQL Server start can lead to hours of degraded performance. So these are just a couple of the many problems that start to come up as the scope of your data increases. A second issue with big data systems is very high transaction loads. It's not uncommon for people to operate constantly at thousands of transactions per second, both read as well as write. This leads to resource contention as well as issues of very basic issues of SQL processing overhead, like time that it requires to go ahead and compile even a SQL statement can become very, very important in this context. Big data systems tend to be distributed both across servers as well as sites. In these types of environments, things like master failover as well as slave promotion become very key issues. We'll be, in fact, zeroing in on that problem, which is something that you're probably familiar with if you run MySQL replication. And speaking of replication, as the number of transactions increase, as you have more time spent going to disk, you have issues with slave lag. This is a really key problem with MySQL systems. So then a final issue is just maintaining continuous operation. Large data systems tend to be 24/7, which means that you don't have windows to do backup. You need to be able to restore things efficiently, and finally you need to deal with problems like system upgrades, such as going from MySQL 5.1 to 5.5. So we'll be looking at software that addresses all of these problems, and with that I'd like to go ahead and turn things over to Vadim, who will be talking a little about Percona Server as well as XtraBackup.
Okay, let's start about Percona Server. So Percona Server is a drop-in, fully compatible replacement for MySQL. The idea behind Percona Server is to solve next problems. It's provide high performance on modern hardware and storage, provide diagnostic instrumentation to diagnose and fight this performance problem, make everyday DBA work easier, provides tools to solve data management problems and issues. And recently we added no SQL way to access data. It's HandlerSocket. And speaking about high performance, we work to ensure good scalability and performance on modern multi-core, big memory, fast storage. The storage is especially important when we speak about big data. And in Percona Server, we continue to do research together with solid-state companies, and we are looking to achieve best performance results. And you can see on some simple graph our benchmarks on TPCC, like our code. This graph was made for MySQL 5.1 version, and we have ongoing work on MySQL 5.5. On diagnostic, in Percona Server, we provide extensive statistics on the query execution. You can see details on a query plan, internal InnoDB timings, profiling how storage procedures, and like that. In addition to, we have a list of information schema tables. Most interesting of them to mention is statistics about tables, indexes, usage, clients, connection statistics. You can see how InnoDB works with buffer pool, using InnoDB buffer pool content tables. And our data management features, besides what I will mention about XtraBackup, and we have an ability to copy only part of InnoDB database from one server to another. We implemented features fast warm up, which allows you to get your slave or brand new server up to speed just a couple minutes on servers with a big buffer pool size. And usually it may take hours, and it seriously affects operation tasks. You can check our recent white paper on the Percona.com website. And also, as part of optimization for flash drives, we integrated work with flash cache to provide hints which data should be cached, not cached. And for reference, flash cache is a technology which uses flash solid-state drives to cache data normally stored on regular or slow spinning devices. And a recent brand new feature, it is no SQL, and HandlerSocket. HandlerSocket is not developed by Percona, but rather guys from DNA, and they provided us plugin, and it easily integrates with our server. And we made it not only to follow popular, not to follow popular trend, but HandlerSocket really allows you to achieve impressive performance results. There is reports to achieve about 750,000 requests per second. With HandlerSocket, you can get direct access to data by passing SQL queries, parser, and there is a wide range of ways to access data. It's not only PK lookups, you can execute lookup by any index you have, and besides lookups, it's also range access, less grade between. And let me touch a little bit our plans. We are looking to get better support for cloud, for scalability and performance issue. Cloud is getting more and more popularity, and it is one of the biggest deployment platform for MySQL installations. So we're looking to get better support for that. We continue researching improve performance on flash and SSD storage devices, and we're always looking to get to more diagnostic. We never have enough statistics to fight with performance problems. Next, I want to go to XtraBackup. Robert, can you help me to switch slides?
Oh, sure. It's not advancing? Let me just double check that you've got.
Yes, it's Percona XtraBackup. Can you go to the next slide?
Sure.
Okay, so Percona XtraBackup, it's a free open source backup tool for MySQL and InnoDB. Originally, it was made as free alternative to InnoDB hot backup from Oracle, but during implementation, we added some unique features which make this tool very useful to deal with big data problems. For a small data size, you may be comfortable with just MySQL dump, but it's not really working when you have tens of gigabytes of data. So just to list features we have, it is non-blocking backup for InnoDB tables. It provides streaming directly to backup server or types. It has the ability to do incremental differential backups. We provide partial backups. We have parallel copy. And I will show you just an example how with minimal actions set up slave with XtraBackup. So speaking about non-blocking, it is probably most important features in XtraBackup. While we do copy of your database, even it's hundreds of gigabytes files, you continue working with the database. Your server handles SQL queries, and your server continue to work. Originally, InnoDB hot backup was able to do only local copy, and we found it is a serious limitation with trying to handle hundreds of gigabytes data set. Very often your server just do not have the same amount of free space as your regular database directory. That's why we implemented ability to produce stream. It's TAR compatible stream, and with that it opens a wide range of possibilities. Couple examples is just you can copy to single file, you can produce a compressed file, and you can just directly copy to remote host and have copy of your data on a remote host. Incremental differential. Working with a big data set, you often do not want to have several copies of the same data. It can be a very serious space-consuming problem, and if you know the data is not changed significantly after the last backup, you might want to copy only changes. And just to have a definition, differential backups is usually backup when you copy changes, signs last full backup, and incremental backup when you copy changes, signs last incremental or differential backup. And the XtraBackup supports both ability. You can just specify what point of time you want to copy changes from. Partial backup. Very often operations team needs to make only partial copy of data. And if your full database is, say, half of terabyte, it is painful to handle this operation when you want to copy only smaller part of the database. InnoDB does not support that, and we implemented that ability in Percona XtraBackup. Oops, I did click. Can we go to back
sure,
to
I'll go back.
setup slave? Yes.
There we
go.
Okay.
It is just an example how in the two commands you can set up slave copying data from working server. So it's just two actions, and you have fully ready data directory to start MySQL and to roll up a slave.
Vadim, I noticed there's a question that just popped up from one of our listeners who said that he tried XtraBackup today, and it ignored in the second test the minus database switch and made a backup of all the databases instead of the one in the option. And he was wondering if he'd ever encountered that behavior. Figure since we're looking at the options.
Okay, well, I cannot answer. I probably will need to look into details and to output, and it should work, but it always can be small bugs, so I cannot answer right now.
Okay.
Can we go to the next slide, please?
You got it.
Okay, so just touch our XtraBackup plan. So we're looking to support cloud or S3 storage. We want to implement features to copy and store data directly from S3 or different cloud storage. We want to implement compression on the table level. As you see from my example, you can do compression on full database, but it's not always useful when you want to do partial backups. And having said, we want also to improve our operations with incremental and partial data sets. So it's maybe not so easy right now, but we're always looking to improve it. And I think that's it from my side, and I give words back to Robert.
Okay, thanks, Vadim. So what I'm going to do is go ahead and talk about Tungsten. One thing I do want to say is that that as we go to Tungsten, we work with the Percona software, and I think it's fair to say that the XtraBackup is actually the most exciting product in some ways because it has such powerful abilities to move data. And this is a big problem as we get into systems that are built on replication, because you always have to provision things and you have to have the ability to recover systems that have failed. So some of these features in XtraBackup are very exciting, and we're working on increasingly deep integration with them. With that, I'd like to go ahead and talk a little bit about Tungsten. So there's a couple versions of Tungsten. We've done some changes over the last few months, and I'd like to just, if you have heard about how things are organized before, I'd like to just refresh your memory, and of course, if you're new, just let you know how things are organized. So our base offering is something called Tungsten Replicator, which is a fast open source replication engine for MySQL. It's not completely open source yet. I'll talk a little bit about our plans, but we do plan to have this actually, thanks to the generosity of some corporate sponsors, to have this completely open source within the next 2-3 months. So the Tungsten Replicator is really focused on moving data very fast and very flexibly, and we'll see examples of that shortly. One of the things about replication, particularly master-slave replication, is you can then build systems on top of it. And so Tungsten Enterprise does exactly that. It's a rolled-up solution for data management that's based on master-slave replication, and out of the box ensures access to your data, simplifies management tasks, and enables you to increase performance and resource utilization. The big thing about it is we seek to do that in every case without forcing application changes. It's basically your application connecting to the database, nobody in between you. Well, to the extent we are, we try and be as transparent as possible, but basically to build the kind of clusters that out of the box that people otherwise spend a lot of time integrating. So with that, I'd like to go in and just talk a little bit about architecture for a few minutes. So in this next slide, I have a picture of the Tungsten Replicator architecture. And the first thing to understand is that this is a complete replacement for MySQL replication. Tungsten Replicator is an external process. It's actually written in Java. We do that because Java turns out for these kinds of applications to be very, very fast. And so what happens is that in a typical scenario or deployment, you'll have a master replicator and you'll have a slave replicator. The masters work pretty simply. You enable bin logs just as you do with ordinary MySQL replication, and then the master can either tail the bin log as it's written to the disk, or even better, just log in as a client and pull the bin log down just as MySQL does itself. The replicator configuration is controlled by a file called replicator.properties. And then we generate our own transaction history log. So this is a separate log that contains all the information that has to be replicated. It includes a bunch of metadata and also includes a very important feature, namely global transaction IDs. We'll talk more about this shortly. The slaves dial up to the master replicator. They pull the logs down, they store them, and then they go ahead and apply them on the slave. So the key thing is that this is an external process. It's not built in, and as a result, we have some very interesting capabilities that MySQL does not. And in fact, just to list a few of those capabilities, I'm running on nowadays it used to be I could get them all on one slide. It's getting a bit crowded now, but it includes an enormous number of sort of external things that you would find in advanced commercial replicators, such as transaction IDs, the ability to filter transactions, the ability to replicate to other databases, time delay replication. You can read down the list. It's actually quite a number of features. One thing I should stress is that if you can replicate it with MySQL, you can replicate it with Tungsten Replicator. There are, as Vadim says, every piece of software has little bugs. There's a couple things that we're not so good at replicating right now. But in general, if you're able to replicate it, do it in MySQL replication, you can do it with Tungsten, plus you have all these additional features. So one of the key things that makes the replicator flexible is that in addition to being an external process, which means that we can run them in different places in the network, we can have multiple processes and scale things up, is we have these things called pipelines. And the replicator is, if you're familiar with message processing systems, the replicator is designed like a message processing system that does SQL replication. So it has these things within it called pipelines, and a pipeline is a set of stages, basically a sort of in, filter, out stages, and they use symmetric interfaces. So, for example, what you see here is a simple pipeline design which corresponds to a slave. So we read from a transaction history log across the network. That can get filtered, so we can examine, we can change, we can drop transactions. They get applied in a transaction history log and then pulled out and applied to the slave database. Much like MySQL, this completely decouples, just as MySQL has an IO thread and a SQL thread, this design completely decouples pulling the transactions from the master and logging them from getting them out of the log and applying them to the slave database. The difference between this and MySQL is that if you need to spread work across more CPUs, you can add more stages separated by queues, and we'll talk about that in a minute, how that works. So this is the basic architecture, and it's very configurable and quite flexible. Just turning from replication to building systems on top of it, I want to just spend a couple minutes talking about or a minute or two on the Tungsten Enterprise architecture. So replication is the base technology that's used to build very large clusters. MySQL has proven this again and again, widely used across MySQL deployments. The way that Tungsten Enterprise builds on this is we have the replicator, which creates the copies. You have software like XtraBackup, which allows you to do the initial provisioning of the slaves very efficiently. What we do in Tungsten Enterprise is we add distributed management on top of that. So there's a manager that runs on each of the databases, and I'll show you what they do in a second. And we also add connectivity options, because once you have multiple servers, it then becomes important to allow your applications to find them without adding a bunch of weird library plumbing. So here's an example of PHP applications. They're connecting to the cluster through our connector, which is a very high-speed proxy. And the connector is managed, which means that it knows where the current master is, it knows where the slaves are, it knows what their latencies are, and it's able to do things like load balancing reads. It's able to automatically stop transactions when we're doing a switch, so we can do a seamless upgrade, for example, or seamless switch between a master and a slave. So this is a very powerful extension of the basic replication. The management itself is distributed. It uses something called group communications, and the really interesting thing about this is it has a rules engine that controls it, and at any given time, one of the managers automatically elects itself the coordinator, and if you have a failure in the system or if a new slave joins or something like that, that manager coordinates the action necessary to handle it. So for example, if a master fails, we automatically execute a set of rules that locate the most advanced slave, stop writes to the system, go ahead and reconfigure to promote that to be master and have the other slaves point to it. So this is all automatically managed. So just to keep these two things apart, I have a little table here. So the replicator is basically focused on data movement, so it has a number of capabilities, including sort of a basic administration tool, which we'll see in a few minutes. It also includes, as I mentioned, support for a wide variety of MySQL versions, multi-master as well as parallel apply, and replication to other database types. So for example, we have a project that we're doing right now to implement replication from MySQL into Greenplum. We're doing that for a big SaaS company. The enterprise then adds distributed management, automated failover, zero downtime upgrades, routing and load balancing, as well as floating IP support. And these are all things that we discuss in other webinars. They're very interesting capabilities. But what I'm going to do now is go ahead and dig a little bit more deeply into the Tungsten replicator and how this operates. So let's get the slides to move forward. So returning back to the theme of big data, one of the things that we mentioned up front is that big data tends to be spread across multiple servers as well as sites. This is very common with SaaS applications. So, and as well as many others, large web properties, things like that. So, Tungsten Replicator has a number of very interesting capabilities to allow you to create complex topologies which are necessary to implement these types of systems. One of the things that Tungsten can do is many-to-one master slave. So many masters flowing into a single slave. This is very commonly used for things like billing or other types of reporting roll-ups from remote servers. Tungsten can do bidirectional replication, but also have slaves hanging off the masters. And then it works cross-site and cross-host. What I'd like to do is show you a couple of pictures that illustrate a couple of these. I think those are better than words. So, for example, this next slide shows multi-master data consolidation, so multiple masters feeding into one slave. And there's a couple different ways to do this. In the existing released product, which is Tungsten 1.3, you can just do it by running separate replicators. So you have multiple masters. You have a master, you have another master, and then you have slave processes as well. So you actually have separate installations of the replicator, which are then feeding into the same MySQL database. Now, one of the things that we have in the next version of Tungsten, which is Tungsten 2.0, which is now in beta, is we have the ability to do multiple services within in a single replicator process. So this is the equivalent of having multiple replicators, but just running in one process. You don't have to do extra setup or anything like that, and that allows you actually to do this very minimal data movement architecture or design where you just have a service for each master, and then it's pushing the data over to into the slave. So another thing that that we're able to do is sort of these, as I mentioned, these advanced bidirectional replication types of features. This is something that we're working on with a couple of customers. So basically, you have multiple masters on different sites. They exchange data bidirectionally, and then the data are replicated down into slaves. This is an architecture that isn't possible in MySQL. It's actually quite interesting. This is a multi-master is a huge subject, so I'm just giving you a flavor of some of the things that we're doing. We'll probably be doing webinars in the near future to discuss this in more detail. One kind of cool feature that I should mention is that the Tungsten slaves, we have some tricks that we use. So the Tungsten slaves, like the SJC local and the NYC local slaves that you see here, are actually able to remember the positions of data from the remote masters, so that in fact we also enable things like failover, so that you can promote a local slave and it remembers not only the position of local updates, but it also remembers where it was with respect to remote masters. Let me talk about another problem, so big data and failover. Slave promotion, particularly as soon as you have more than one slave, is a really big problem, particularly for applications that have high transaction loads. As you probably know from MySQL, if you have an emergency failover or an unplanned failover and you have multiple slaves, you can promote one to be the master. That's pretty easy, and MySQL actually makes that very easy to do. The big problem is hooking up the other slaves, because those slaves remember their position by holding references to bin log files as well as offsets that are on the master file system. As soon as you move to to another master, it has a completely different set of offsets, and now you have to figure out where you were. So there's some kind of evil bin log hacks that people sometimes do to deal with this problem, but Tungsten basically makes all of this stuff go away with two big things. First is global transaction IDs, that basically every time we read a transaction out of the log, we assign it a global ID. And every slave knows that ID. It's not tied to any file system. It's just an integer that keeps increasing indefinitely. The other thing we do is we put in what are called epoch numbers. And epoch numbers prevent reconnection when the logs have gotten screwed up and are diverging. And we'll see an example of that right away. So here's a picture that shows how this works. It's really kind of different from MySQL, but basically you have a master, you have a slave, you got the replicator log, sequence number, epoch number, and basically what happens is the epoch number is set every time a master goes online. Whatever that sequence number is, that gets assigned as the epoch number. And so in this table we can see that the master went online at sequence number 1. It may have gone offline after 2. It went online again at 3. And what this does is it allows us to compare the bin logs or the logs and make sure that they're consistent so that somebody doesn't accidentally connect to the wrong master. Another interesting thing about the sequence numbers and the epoch numbers, it means that you can take a backup from a master, you can take it from a slave, anywhere basically, and you can reload it without any problem. So you can it makes reprovisioning and backup much simpler. Here's examples of how it works. A big case where this becomes very important is when you're crossing sites. By definition, when things go down on sites, you can't see, you lose file systems. So here's an example where we have a DR site set up. We use a trick with floating IPs to make this work. Your master is at sequence number 35, and it's at epoch number 1. And then you have the slaves various distances behind, but they're all at epoch 1, which means that their logs are basically consistent with the master. Let's say, for example, we have a failover. Well, at that point, your slave on the main cluster site gets promoted. It writes sequence number 29. It says epoch number. It makes its epoch number 29 because that's when it went online. So what's kind of cool about that is that, first of all, the sequence number is global. So those slaves that are off on the remote site, they'll just switch over when the IP address flips over. They'll just connect up and they'll say, please give me more data. But another really key thing is that the old master now cannot reconnect. What you see is a case here where you've actually got data marooned on the old master. It's a few transactions ahead. But if it tries to reconnect, the new master will say, I see you want sequence number 35, but you're asking for epoch 1. I should be epoch 29. I'm not going to let you connect, so it prevents you from corrupting your data. And we've had we found this. We use this in production. It's a very, very helpful feature. So that's basically the Tungsten global IDs. I'm going to talk about a final area, which is parallelization. And much as Vadim talked about in the Percona server, as the data gets large, as the number of transactions grows, you get issues with resource utilization. And single-threaded MySQL replication has a really severe problem because there's an impedance mismatch between CPU and I/O as your replication volumes get large. I think everybody knows, most people who run MySQL and large data sets know about slave lag. That's basically caused because you have single-threaded apply of things on the slaves, and so if it takes a while and you have to go to disk, all the other transactions wait. Tungsten is designed because of this messaging architecture to solve that problem. And what we do is enable a variety of different parallelizations that allow you then to kind of match up the power that you have in CPUs, but also match it up with I/O weight, to sort of match that up and not get blocked by I/O weight. There's actually a variety of ways that you can parallelize things. There's what we call pipeline parallelization, which is adding more stages. So every stage uses one or more CPUs. So if you've got CPU-intensive stuff and that's holding you up, just split it into separate stages. Another thing you can do is service parallelization, or parallelism. So you can add more services, split things out into separate processes, have different services with their own logs. And then finally, you can do parallel apply. And parallel apply has been something people have been pretty interested in for a while on MySQL because it solves one of the big blocking problems, namely that the MySQL thread is just one thread. So I'm going to look a little bit more deeply at how parallel apply works, but this also kind of illustrates some of the other parallelism as well. So in Tungsten 2.0, we have extended the pipeline architecture, the standard pipeline architecture, to add an extra stage, and that stage has a parallel queue. And so what happens in that queue is as we read things out of the master, we sharded them. When we get to this queue, we distribute them across the different queues within it based on their shard ID, and then we have multiple threads in the final apply stage, which can then write the information onto the slave database. This actually works pretty well for a lot of applications, and what I'm going to do is show you a quick demo of this. The way that it works is we run 3 TPCBs in parallel. They're each writing to different databases, and this is actually a very good simulation of the kind of thing that happens in multi-tenant systems, where every tenant has their own database. So these guys are jamming data into the server. It gets pulled out by the replicator, which assigns a shard ID, and then it's going to be sent over to the slave, which in this demo has 5 channels available. So it's going to use 3 of them to apply the data. And so with that, I'm just going to pause for a second here and go ahead and switch over to my demo. Just 1 second while I bring the screen up. Okay, so I'm going to go ahead and show you the screen. So what we have here is you should see 3 windows on my screen, and 2 of them belong to my master host, which is Logos 1, so those are the little ones on the left side. And we have a big one on the right side because there's more to show there, and that's the slave. So what we have right now is we have the services running on the replicators. I'm just going to show you, use this little TREP-CTL, that's the management client. I'm going to just say services on the master, and what this shows me is I've got a single, when your screen refreshes, I have a single service running in this replicator. It's a master. Its last sequence number I just restarted or just reinitialized, so it's currently on sequence number 0. If I come over to my slave, similarly I have a single service there that's running a slave. It's in the slave role. It's running a pipeline that's configured for slaves, and there's just one of those as well. Now, in these types of parallel replication cases, it's kind of interesting to look at a couple other different views. There's a view that we can show on the slave, which is to show the tasks, in other words, to see what the actual threads are up to. So we're going to go ahead. Oops. We can show you that, and it's a long listing that just shows all the threads within all the stages. And when your screen refreshes, you see 5 threads here, and these actually represent your parallel apply threads. And we can see each of them. It's kind of interesting. Each of them knows what's the last event it processed, what's the latency of transactions on that thread, so they're on the order of about 2 seconds or so. We can actually push something through just to check liveness of the system. We'll put a heartbeat through. We will check the latency, and the latency goes down. It's now less than a second behind. Another kind of interesting view on this is to look at shards. And so what I've done is just shown a status on the slave that showed the current shards that it's processed. And here we have, see that there's only one shard that's been processed since this replicator was started, and that's the shard that's used to handle tungsten metadata. With this, I'm going to go ahead and actually log in to the Percona server. You can see the tagline up above. I'm going to go ahead and use a database. See if I've got tables out here. I don't. Let's go ahead and just create a table in this database DB1. So I went ahead and created it, and now let's go look at the shards on the slave. So what shards does the slave know about? Well, now it knows about 2 shards because we recognize that that database is a separate shard, and so we show that that has been applied, and we can see that in fact DB1, it last applied sequence number 2, essentially 0 latency, so it looks like this guy's fully caught up. Either that or my clocks are off. And so we now have that. Finally, so basically you can see that these things are being applied in parallel. What I'd now like to prove to you is that this actually works under load, and I'm going to start this TPCB example. Let's pull that up. So we're going to kick off the TPCBs. We're actually going to tail one of them just so that we can see what it's doing, so that it appears to be, just a second. There we go. So we can see it's creating its tables. This is a little banking simulation. And if we now come over to the slave, we can go ahead and look at the status of the shards, and now we see that there are 5 shards. So the shards are being picked up, and we're tracking each of them and applying them in parallel. And then finally, if we go back and look at our tasks, we can now see the effect of the parallelization. So I've just shown the tasks, and if you look in this listing, you'll see that there's 3 of the tasks have actually gone ahead and applied about 6,000 or 7,000 transactions each, and 2 of the tasks have only applied a couple hundred. The ones that have applied, we have 3 databases in this demo. They get hashed out to the different threads, and so as a result, we see this. We see the parallelization in effect here. One final thing that that I'd like to do is just demonstrate that this system is pretty robust and can withstand crashes. So if you're familiar with the whole parallelization problem, it is very difficult to ensure that we pick up at the right point for each of the shards. Tungsten is crash safe, not only for single-threaded but also multi-threaded or parallel apply. So what I'm going to do is just go ahead and restart the replicator. And this is just a simple kill the process. I swear to you it does no cleanup whatsoever. So we're going to do a restart, and now what we're going to do is go back and make sure that our service, our slave service, has restarted. Oops. If I type the right command. Okay, the slave service is restarted. It's online, so it was able to restart without errors. It didn't get confused about keys. And if we now go back and look at our at our shards, we'll see, sure enough, there's all the shard data going through. And this time it only has 3 shards because it loses its memory about the shards that it had previously applied, and it just restarts all the counters. But we now see that the shards are working again. So basically what we've seen here is we put some load on this system. We've shown that it replicates in parallel. We've shown that we can crash it, and it comes back and continues replicating just fine. So with that, I'd like to switch back because we'd like to talk a little bit about, well, first of all, future plans. So what you're seeing here will go fully GPL in 2011. We're really excited about that. We've had some corporate sponsorship that's helping us do this. And we do look forward to sort of having this stuff get out there and be available under the same terms as Percona software. We will have, it's going to take us a little while to get this fully out in GPL v2, so we'll have a couple of, we'll have replicator-only builds that are still not, that are free but not commercially licensed, or not fully open source licenses. They will be available in February. And in fact, the plan is to have them out next week. So keep an eye on that. With that, I'd like to come in and talk a little bit about the commercial services, first of all for Continuent, and then we'll let Vadim talk a little bit about Percona. So we, as I mentioned, do product subscriptions on the commercial software. So it's per server, based on the number of database servers. The more you have, the cheaper it gets. We have a couple different licensing schemes. Software only. This is really good for people who are OEMs or very, very technically competent. Of course, there's many of you out there. You basically just pay to run the software, but there's essentially no support. Obviously, we fix bugs, but we're not going to help you with configuration. Use consulting for that, so you can scale it up or down depending on what you need. This is great if you want to OEM it. Then we have, if you're running a commercial site and you want the full kit and caboodle, you can do software plus support, which is license plus 24/7 support. Generally speaking, it is 24/7, although obviously the SLAs are negotiable. The consulting, we've been doing this for a long time, so we consult on just about anything to do with either Tungsten or replication. That's really, and replication/clustering, that's our area of expertise. Everything from hourly support to special projects to sponsor development, and we've had sponsor development all the way from, you know, like major features down to things that took us 2 hours to put in. We're very open-minded. If you need something, we'll put it in. We do that for both commercial as well as open source software. And with that, I'd like to turn this over to Vadim to talk about some of the really cool stuff that Percona does.
Yes, hello. So Percona is a consulting company, and our main product is consulting. We specialize in MySQL architecture design, diagnose and solve performance problem. We can help with recovering data, set up high availability schema, clustering, and basically everything around MySQL, and even full stack LAMP optimization and services. So if you looking for some help in that area, you can ask our consulting services. We also provide support and maintenance. If you need to get answer on something around MySQL, Percona Server, Percona XtraBackup, or you're looking to get some bug fixed on a prompt basic, or you need to get some customized MySQL binaries with custom patches or with some custom specialized platforms like Amigo OS and so on. And we provide training. It's both public and custom courses. Public courses you can see on our website, and if you need custom developed training for your staff and your team, you just can inquire us. And again, we provide software which usually and always will be free, open source. You can use it without any fee and not pay any payment. But if you look for additional help, additional features, you can always inquiry and ask Percona. Okay, Robert?
Great. Yeah, and I want to say something that I've worked with both Vadim, as Peter, and Baron, the other principals at Percona, because we've had projects that we've shared, and they're just really super. I learned more in an hour from them than just about anybody I've ever worked with. So it's they're really very, very good. And whenever we have issues with with MySQL performance problems, they're always the first guys I think of. In conclusion, we've talked about some of the challenges of MySQL big data. You guys are out there, you're running, databases that run, to be big for MySQL, it's anywhere from 500 gigs up to a couple terabytes. So volumes, transaction rates, all these problems. We've covered Percona Server, XtraBackup, and Tungsten, shown you how we attack these problems and are continuing to attack them in the future. And we'd like to invite you to think about combining Percona and Continuent for your next project. We've worked together in the past and very much look forward to doing it in the future. So with that, I'd like to give you some contact information. Just remind you that you can get a copy of the slides from sales@continuent.com. You can get hold of Percona at the contact information shown here. Please do keep an eye on both of our websites. Percona, my goodness, I'm so sorry, Vadim, we've got a misspelling there. Percona website, they're doing constant releases of their software. Continuent has regular releases as well, so keep an eye on what's going on. And with that, I'd like to turn it over and try and answer some questions for you. So let's see, we already had one about XtraBackup. Conventional MySQL replication is a serial process. How is it when you have more than one master to one slave? This is, by default, it's still serial. So it's still single-threaded apply, but you could also actually have parallel apply as you're putting it into the databases. Now, generally speaking, that's probably not something that you need to do. It depends on how much data you have, but it's basically anything you want, and Tungsten is really as configurable as you want. The pipelines are set up in a configuration file, and you have a lot of flexibility. Vadim, I'm just going to take these in the list. I've got the next one is why slaves on let's see. Oh, okay. So, a question about the picture on that we had on remote replication. It might have been a little bit confusing, but the old slaves continued to have their old epoch numbers because they hadn't gotten new updates. And the thing is that when the slaves connect back, they say, "Here's the last thing that I got from you, and here's the number, and here's the epoch number with it," and that's okay, because when we look in the log, we see that, for example, sequence number 28 still had epoch number 1 because it was generated on the old master. But when the new master comes in, he says, "Hey, I'm epoch number 1, but I have sequence number 35." And the new master says, "Oh, no, you don't, because I have a different epoch number, so I don't let you connect." Let's see. Routing, Tungsten is very interesting, but can you tell us whether and how well it operates with MySQL Enterprise Monitoring and the MySQL Enterprise Query Analyzer? That's a good question. So the monitoring, we don't have integration with it. So for example, MySQL Enterprise Monitoring is pretty good on things like at least displaying what's going on. It does not know about Tungsten. And it does not know about our replication. That's something that we have not integrated. And then MySQL Enterprise Query Analyzers, I haven't really tried it out. As far as I know, because that goes straight to the database, you would just be able to use it. It would not, you shouldn't see any issues there. However, if, as I recall it, I think that may be based now on MySQL Proxy, which may introduce some interesting issues because of, possibly because it's trying to find trying to find masters and slaves or something like that. So we haven't really tried it. And so I have to give the same answer that Vadim said. We'd have to look into it. Does the replicator solve the table locks problems on a master-master write load balance? We don't do anything special for that. So in fact, one of the really cool things about Percona Server is right now we don't solve that problem, you do run into issues where things are locking. Percona has really good diagnostics. I was using them yesterday to deal with a bug that I hit in something else. So they do help you. We will be doing some work on conflict resolution later in the year, and we also have some ideas on tap for things like lock-free consistency checking, as well as data repair, but those are roadmap things that are really pretty far out for us. Is the sharding configurable? Yes, it is. So right now the default implementation is based on databases. But there's two things you can do. One, you can write your own sharding algorithms. It's all done through filters. It's highly extensible. It is, and the other thing that I didn't mention about it is it's a little bit smarter than, it's not just dumb sharding. It also knows about typical multi-tenant systems where you have centralized data that everybody shares, but then you have other shards that are independent for different tenants. And so you can declare that like a shard is shared, and then we basically, whenever we hit data from that shard, we'll actually shut down parallel replication, apply it in serial order, and then as soon as we're done, we'll open it back up again. So that's a fairly significant feature. Let's see. Can you show the slide for show slave status when a slave has more than one master? Okay, a good question. We don't actually. What you do is you don't use show slave status for our system. It's basically shut off. We are doing some work that may change that in the future, but for now you basically use our tools to see where the replicator is. Once the replication is started, it's using Tungsten stuff. Let's see. Just trying to go down and see if we. Okay, if you guys have questions for Vadim on Percona Server or XtraBackup, please please bring them up, because he's definitely the authority on that. And as you probably know from the great articles he writes on MySQL Performance blog. Let's see. Is it possible to know if a slave is completely in sync with the application? Yes, actually, this is a sort of a deeper topic that isn't really a one-line answer. We have done some interesting work on session load balancing. And Vadim, have you? I know this is something that Baron has worked on. You guys, but I don't think Percona doesn't do anything special. Have you guys done any work in that area?
No, in that area, we did not touch.
Yeah, because there's actually kind of a division between what Percona specializes on and what we do. So we have this thing called session load balancing that I'd recommend you look into. And in fact, it actually allows you to, basically what it does is if you have a bunch of different databases that you're using, for each database, we'll track your position in the bin log and when you're doing writes. And then if you come to do a read, and this is done in the proxy, we'll then say, okay, we see that you have a read that's eligible to load balance. We're going to go look in our records and see, what's the bin log position when you last wrote, and we'll load balance it onto a slave that's caught up to at least that position. So it actually meshes fairly well with this sharding. It's a very interesting way of doing load balancing that can result in really, really good scaling for multi-tenant applications. So we have that, but we do not currently yet support semi-sync replication. Vadim, you guys are coming out. You guys are going to have that. When's 5.5 coming out for you guys?
Okay, we actually hello. We expect Percona Server 5.5 beta ready by Percona Live conference in San Francisco, and more stable release candidate and stable release probably later in March, and stable release maybe by MySQL user conference in April.
Yeah, and we're sort of tracking what Percona is doing. Of course, the Oracle builds are out. They've been out production for months, for 2-3 months now, and we will be adding support for semi-sync replication. Tungsten will be able to detect that and actually play along with it so that you can get guarantees that things have been pulled off. Is parallel apply only applicable with different databases? I think this is, right now that's the default way that it's done. We you know, so we can definitely, but we can extend it. To be frank, for multi-tenant systems, databases are so common that we did that first. That's one that we see in the SaaS application work we did, and I think corresponds. Vadim, that sort of corresponds to the work you guys did with XtraBackup to be able to dump databases for individual tenants. Is that correct?
Yes.
Yeah, because I remember seeing some of your white papers on that. That said, if you have other schemes, talk to us. That's a great example of where we can do sponsored development, or you know, and if you want to do it yourselves, that's a good example. Hey, here's a great one. Vadim, do you have any way to reduce the size of the IB data 1 online? The only way I know is doing a backup, deleting a full database, and restoring it again.
Oh no, but it's actually in our also work roadmap. I cannot promise any specific date, but we're totally aware it's maybe quite issue. And actually, there's a couple of bugs in MySQL which recently reported and should be fixed in a new version of MySQL 5.5, but it's still some work to do. So we're aware about the issue and we're looking to resolve it.
Okay. I got another one for you. How would you compare XtraBackup to traditional LVM snapshot backup?
Okay, so to traditional LVM snapshot, I think LVM snapshot has two drawbacks. First, when you activate snapshot, it writes becomes very slow, and it might significantly impact your production database if you load write intensive. We have benchmarks related to that on MySQL performance blog. So you're welcome to come and see our benchmark results. And another issue with LVM snapshots is all your data, log files, IB data, and tables files should be on the same partitions, while in flash drives setups, we recommend to have logs separate from data partition, and in that case, LVM snapshot cannot provide consistent data, and only XtraBackup handle that properly.
That's a good point, and I'd like to further add that if you really are looking at LVM, in addition to the performance problems, LVM lacks, at least in the kernels that most people are running, LVM has no merge capability. So you can't flash back. I mean, you can get back to an old snapshot, but it's by copying blocks using the DD command. There's a kludge. You know, if you're seriously, there are some advantages to this kind of file system snapshot, you know, modulo some of the issues that Vadim brought up, but I think if my recommendation would be, if you're going that way, think about a SAN or NetApp, something that has, for example, data deduplication and the ability also to provision stuff rapidly in other locations. LVM doesn't work on large systems. Okay, I think we're at the end of the questions. I would like to thank everybody very much. I'm glad you guys took the time to listen to our webinar. I'd also like to thank Vadim. Vadim, it's always a pleasure working with you, and I hope we'll be on some projects together as a result of this.
Yes, absolutely. Thank you, Robert, for the invitation, and I think we had a good webinar, and thank you for all attendees.
Great. Thanks, everybody. Have a great day, and talk to you soon.
Thank you. Bye-bye.